Hello, everyone, and thank you for joining us. We have an interesting webinar planned, and we'll get started in about 1 minute. Hello, everyone, and thank you for joining us. We have a very special webinar planned today. This is episode 31 in our Graph Gurus series. It's hard to believe we've now produced that many of this series, and we try to make these as informative as possible. This one is called GSQL Writing Best Practices, and it's part one of a series. Not quite sure how many there'll be in the series, but I would think at least 3. And part one, this episode is the first, and appropriately is titled Thinking in GSQL. I'm David Ronald. I'm Director of Product Marketing at Tigergraph. My background is shown here, a bachelor's in physics, a master's in physics. And I worked in a number of technical fields with about over 18 years experience in the tech industry. Much more importantly, however, I am joined today by my very esteemed colleague, Xingyu Chang, who is our Director of Customer Solutions. And he was one of the co-authors of GSQL, the graph query language that we use here at Tigergraph. And so it's very appropriate for him to be presenting today. And there is no other person who is more capable of giving a very informative webinar and addressing questions you have about GSQL. He has developed solutions for many companies, not just Fortune 50, but big and small companies globally. He joined Tigergraph in 2014, so he has over 5 years experience. I think he's got about 5 years and 8 months. And one interesting thing about Xingyu, which I'm not sure if he wants me to share, but which I'll do so anyway, is that for his bachelor's degree, he studied computer science and also Japanese, which I think is a very interesting combination, and it shows the breadth of his curiosity. Before we get started, 3 housekeeping items to cover. We have muted your phone lines, but that's not an indication that we don't want to hear from you. Quite the opposite. We would love to receive your questions. I encourage you to submit them at any time throughout the webinar, and you can do that by clicking on the Q&A button in the menu. This webinar is being recorded and will be uploaded to our website shortly, and shortly means typically 2 to 3 hours. So if you're eager to review it, you could plan on doing that later today, certainly tomorrow. And we will, in addition to uploading the webinar to our website, we will also email you a link to the archive along with the slides and any other relevant materials that Xingyu wants to include in that email. Last but not least, if you have questions with Zoom, please contact either of us, either myself or Xingyu, and we'll do our very best to resolve them as quickly as possible. And with that, I'm going to pass control of the webinar to Xingyu.
Okay, thank you, David, for the great introduction. So that actually means even someone's graduated from foreign language school, they can still write good GSQL queries. So let me share my screen. So this will be today's agenda. So this is the first episode of the new series on the query writing best practices. So in the future episode, we will also cover other topics like how to define optimal data structure, optimal accumulator structures, and how to write memory saving queries, as well as how to parallelize the query logic. Okay, so this is the first episode. We will start simple. We will review the basics first. And then I'll talk about the thinking steps of writing a query, what to think about, what are the questions to ask when you start to write a GSQL query. Then I will practice those steps by giving 3 query writing examples. Okay, then I will do like a live query writing to practice those thinking steps. So in this tutorial, we assume you already have some GSQL query writing background. However, we'll still review the basics real quick. So if you are interested in more videos about GSQL, and it's absolutely recommended to watch this series of a video that is on select statement. Okay, we have a whole list of videos, including the demo, the query writing demo, and the very detailed introduction of each component of a select statement. This is very practical and useful. Okay, and then let's get started. So let's start with reviewing the basics. So when we write a query, usually a GSQL query has 2 sessions. On the top, we define the query name and the parameter names, right? And in the query body, we have 2 sessions. The first session, we define all the data structures. So in the second session, we define all the query traversal logics. So they cannot overlap. So we have to define all the data structure we need to use in the beginning, and then we write the query, say where do we start from, and what's the traversal logics. Okay, and so what does GSQL do? So easily speaking, it's nothing but you start from one set of vertex, and you through some selected edges originated from the starting set, and then you traverse to another set of vertex. So it's like this. You're always starting from somewhere. For example, you want to say, okay, I want to get all the patient has a claim belongs to a doctor of a certain specialty, right? In this case, we always have a place to start with, and then we select some edges, and then we traverse to another set of vertex. And then we select some edges, we traverse to another set of vertex. Just to repeat this again and again to hop from one place to another on the graph. So that is what GSQL do, right? It's just simple like that. Just a hop to different places on the graph. So knowing that, so we know that GSQL always has to start from somewhere. So that means we need to, in the query, the first thing we want to do for the traversal is we need to define a starting point, right? So this is how we do it. So if we look at the query here, it takes the input vertex type input parameter, and then we created a vertex set variable named start set out of this input vertex, right? So this will be your starting point of this query. So here, start set is a variable name. Is a variable name of vertex set variable. So here, vertex set variable means it is a set of vertex, right? It's a set of vertex that you can, with a select statement, you can start from that set of vertex set. And it is also, a vertex set variable is also the outcome of a select statement. So in this case, the vertex set start set only contains one single vertex that is your input parameter. Okay, and this is always the recommended way to start your traversal logic. Why? Because I see a lot of GSQL writers, they would like start from all vertices under that type and find the one's ID equals to something, but that is really slow because it scans over all the vertices, right? And this is the most this is the fastest way to start from a single vertex, and this is a recommended way. Okay, and alternatively, we can also start from a set of vertex, right? By taking a set of vertex as a parameter, then create a vertex set variable out of it. And later I can just start from it. Or we can start from all the vertices belongs to a certain type. Say, I want to start from all the claim vertices, or I can start from all the vertices in the graph. Okay, so this is how we define the starting point of your traversal logic. You can start from vertex, from a set of vertex, from a type, or all vertices. And once we have a starting point, now we can define the select statement originating from that starting point, right? We can select some edges and traverse to another set of vertex. And this is almost the hello world of a select statement. You can see in the first line, line 1, we define the start. This is a vertex set variable with the value of the input vertex, right? And then starting from it, we selected all the reverse associated edge, and then we traverse to claims. So that is given the input patient, like that is this vertex. I traverse, I'm doing a pattern matching, something like that, right? So pattern is starting from the start vertex set, and select all the edges attached to it, and then find all the target vertices under the type claim. So that is what this select statement does, right? So if you look at the chart, starting from the input patient, select all these 3 associated edges, and then we say here, you can see we selected T. So what is T here? T is an alias of your target vertex. And your target vertices are these 3 vertices on the right-hand side of the edges. Okay, so that means since I have selected T as the result of select the statement, then that means the outcome of the select statement will become these 3 vertices. So therefore, we assign the outcome, the return value of the select statement to a new vertex set variable claims. And in this case, the claim will contain 3 vertices. That is claim A, claim B, and claim C. Okay. So that is how we write the simplest select statement, and what is the meaning of each word in this statement. Okay, so but we can actually add a lot more to a select statement. So this is the backbone of a select statement. So other than what we already have, like from and select, we already have select and from here, right? We can also add a where clause to add a filtering on the edges, right? We can do a accum to define the logic you want to behave on all the edges in parallel. And the post accum, we can define all the logics you want to behave on all the vertices. And I mean, by all the vertices, I mean all the vertices you traversed in this hop, okay, not like globally all the vertices. And the having clause is for applying some filtering logic to the vertices being selected. And in the end, you can order them based on certain value attribute or accumulator and choose the top K result in the vertex set variable. Okay, so that's everything we could have in the select statement on top of the hello world version. So if you are interested, you can look at the series of GSQL lecture video to see the details of each clause in the select statement. Okay, and then accumulators. So as we know, like Tiger graph execute its logic in the MPP way, like that is massive parallel processing. So a lot of calculations, they happens in parallel. Then in this case, we need a special variable to handle this when we want to assign value in a parallel manner, right? For in this example, like we are sending value 1, 1, 2 from 3 locations, that is 3 edges, be DE, DB, and DC. From all these 3 edges, we are sending 3 different values to the same variable. Then that means we need to have a way, we have to have a mechanism to aggregate the value without conflict, right? So what we do is, in the first phase, we store all the values collected into a temporary bucket, okay? And then the next phase, once we received all the messages, we aggregate them into a new value of the accumulator. And then, since then, the new value of the accumulator will become accessible. If you are familiar with Hadoop or other big data platform, you know this is actually a map reduce process, right? It takes 2 phases so to assign the value to accumulator. So the phase 1 is receiving the messages. The messages received will be temporarily put to a bucket that belongs to the accumulator. And the phase 2, the accumulator will aggregate the message it received based on its accumulator type. We'll come to accumulator type later, okay? And the aggregated value will become the accumulator's value. And since then, this value will become accessible, okay? And this analogy of accumulator, it's like, just like, for example, in the classroom, there is a teacher. The teacher wants to collect all the papers from all the students and calculates an average score, okay? And in this case, the teacher is the accumulator, right? And the students are the vertex and the edges. And the test paper is the messages sent to the accumulator, right? And then the average score will be the final value of the accumulator, because it just works in a way how accumulator does, right? Like in the phase 1, the teacher would collect all the test papers from the students. That's just the phase 1 of the accumulator, right? Receive all the values and store them in temporary bucket. And then phase 2, the teacher would grade those test papers and calculate the average score of the class. And that's the second phase of accumulator. It aggregates all these values into a final value of the accumulator, okay? So that's, and we have, for accumulator, we can define it in different ways. We have local accumulators and global accumulators. So for local accumulator, it is defined on every each vertex. Not every each vertex, literally. It's like it is defined on all the vertices you traversed, okay? Only the one you touched. So we'll define like some accum at A. So here, single at sign means this is a local accumulator or a vertex attached accumulator defined on all the vertices you traversed. And on the other hand, we have global accumulator, which is defined outside the graph in the global memory of this query. And it is, you can see it starts with 2 at signs, means it's a global accumulator. So you see this one is outside the graph, okay? So that is something stored, visible to all, and is something about your graph, right? And usually a vertex accumulator is something about your vertex. Okay, and for accumulators, we also have different accumulator type. So the type of the accumulator that decides how we aggregate the value. Remember, we mentioned that the first step, we collect the values into buckets, right? And then the different type of accumulator aggregates the value in a different manner. Like for the first one, if for some accum, it has old value 2 and receive new value 135, and then when we try to aggregate the old value and the new value, we will take a sum of all these values, that is 11, right? And for max accum, when we aggregate all these values, we take the maximum, that is 5. And for min accum, we take the minimum 1. And the average accum, which we get the average number, that is 2.75, right? So other than this, all these scalar types, we also have container type of accumulators. That is, if for a set, it maintains a collection of unique elements without an order, right? Unordered unique elements. So if it has old value 2 in the set, then after receiving new values 1, 3, 3, 5, then it will only keep unique values. So it only keep 1, 3, right? In the end, the new value of this set will be 2, 1, 3, 5. And for a list, it keeps duplicate values, but in the order, right? So if you have old value 2 in the list and receive 1, 5, 3, 3, then this is a new list of elements in your list. Okay. Similarly, we also have map as a key value store and heap accum as an ordered top K structure. Okay. So it's all about how you aggregate the message you received in the bucket. Okay, and that's the accumulators. And you can populate accumulators from the vertex and the edges just like this. Now I'm sending, like for this example, we are sending 1, 4, 10 to the local variable defined on this vertex, right? And this time I'm sending the value to a global variable. So we can do that in the, if we go back here, we can populate the accumulators from accum clause and the post accum clause. If you do it from accum clause, you are doing it from edges, hopefully. And for post accum, you are doing that from vertices. Okay, and now let's move to the thinking steps. Because sometimes when we try to write a query, we know all the knowledges, we know the clauses, and the accumulators, but sometimes we need to ask the questions to start with. We need to know what to think about first and where to start with, right? Okay, so these are the questions to ask to help you start with writing the query. So the first step, we need to design the traversal plan. The questions to ask is where to start from? What are the steps? How many hops do you want to traverse? And what are the edge types you want to traverse each step, right? And then once we have designed the traversal plan, we can think about, okay, what about the data structure? What do I need to be in the result? So in order to get that result, where is the info needed in your traversal path, right? Where are they? Where are the needed information? And in order to gather the information together, what accumulator should we use, right? And then we can get our accumulator defined. And once we get the accumulator defined, we need to think about, okay, how to populate the accumulators, right? How do we gather the information to the right place? And then we can finally produce the final result and print it out, right? So these 4 steps and all these questions is the thinking flow when we write queries, okay? And let's take 3 examples, and each example we will go through all these questions to think clear about how we should write this query. Okay. So the first example is to order the specialties in descending order by the number of claims. Okay, so order the specialties because each specialties will have a lot of claims, a lot of that doctor of that specialty, right? We want to order them in the descending order based on the number of claims. Okay, so here on the right-hand side is the schema. Here is where specialty is. Specialty has a subspecialty. Subspecialty has some doctors belongs to that subspecialty, and each doctor can have a lot of claims, and each claims also is associated to a patient. That's how the schema look like, right? So we want to try to answer all these questions based on this schema. Okay, so first question, where do we start from? Okay, so let's look at the schema. Should we start from specialty? Then start from specialty, we can traverse all the way to the claims, and then maybe we can do a count. That's one possibility, right? How about, what if we start from claim? We can also start from claim, traverse to prescriber, and then subspecialty, and then back to specialty, right? So these two, both of them are possibilities. However, when we carefully evaluate the both, I think the easier way would be starting from the claim, right? Okay, if we start from the claim, let's see what are the steps, okay? So if we start from the claim, it will be from claim to prescriber, and then to subspecialty, and then to specialty, right? And what are the edges to be used? And I think that's very straightforward. Submit, of course. And then subspecialty to prescriber, and then specialty to subspecialty. It's very obvious to answer this question, right? Okay, now we get this cleared out. I'll come back to why we don't start from specialty later. And the next question is, in order to choose and define the accumulators, what is the final result? Okay, so since the question was asked is order the specialties in a descending order by the number of claims, right? So what we need is a number of claims on each specialty, right? So we need a number of claims. So that means, okay, so the final result would be specialties ordered by number of claims. We need a number of claims. That's what we need in the result. That is also very obvious. And then the question is, what is the info? Where is the info needed in the final result, right? Of course, because we want a number of claims, of course, the value is on claim vertices, right? Because we need to count the number of it. Okay, and the next question, what accumulator do we use? And now, since we need to count the number of claims, so looks to me, if we scan through all the accumulator types, looks to me that is sum accum, because this one counts the some number of values, right? We want to count the number of claims, so since we need the sum accum in this case, not the others for sure. Yeah. So in this case, yeah, I think we need to define sum accum for this case, right? And the last question, how do we gather the info to the right place? Because right now, the info needed is on claim, right? And we want to count the number with the sum accum. However, in the end, we want to order the specialty by the number of claims. So we need to pass the number all the way to specialty in order to get the count of claims, right? So that is, so the solution will be pass the number of claims from claim vertices all the way to the specialty vertices. Okay, let's write a query based on the answer of these questions, okay? So now we already, we have straightened out like what is the traversal path and the edges, and let's just write a query based on that, okay? Order special. Okay, so we don't need parameters, right? Because we are doing this for all the specialties. And we also know, okay, look at the cheating sheet. Where do we start from? We want to start from claims, right? Okay, then let's just start from claims. Claim. Okay, and this is how we start from a tab. And next thing, and this is traversal path, and these are the edges will be needed, right? So in this tutorial, we only write queries in syntax v1, because right now at this point, syntax v1 has all the features supported and it has best performance, right? So let's stick with syntax v1 first. And if you are interested like in how to do a easy query writing, you can check our document to learn about syntax v2, okay? So, okay, so these are the edges we're gonna use. Let's keep them here. Okay, so we start from that. First, we traverse to the prescribers, right? From start, and this is the edge submit, right? Submit, right? So this is the simplest select statement. And now we get the prescriber, and from prescriber, now we are going to subspecialty, right? And next time I'm using this edge and the traverse to sub, right? And just simple like that. And now I'm going to, from subspecialty, I'm traversing to specialty. From subs. And this is the third edge we're going to do. Okay. Oh, whose name is a little bit different. Subs by, oh, so okay. Okay, and this is our traversal plan. It's simple like that, right? So, okay, so now I have done this, and let's go to the next. Okay, so now we know that we need to define a sum accum, right? Okay, let's define the sum accum here. Say claim count, right? So, okay, and we also know we need to, in order to populate this accumulator, we need to pass the number of claims all the way from claims to the specialty, right? So now we have claim numbers right here from the starting point. Then with the accum, I can pass along the number, right? Hey, oh, I got name wrong. It should not be claim. This is the prescriber, right? I should select prescriber. Okay, and then now let's pass the value all the way along to specialty. Okay, so prescriber count. Okay, so what does this mean? So pres is the alias of the target vertex, and the target vertex is the prescriber vertex, right? That means for each edge starting from claim to prescriber, I will increment the accumulator defined on this prescriber by 1. Okay, pretty much depends on how many edges that is from claims to prescriber, and then it will keep a number of claims of each prescriber, right? And now we have the number of claims stored on prescriber. Next thing, we are passing this, we just get to count the number of claims of each prescriber. Now we are passing this value along to subspecialty, okay? And say accum. So now subspecialties, this is what we want to populate, right? Because equals to the claim count of these prescribers, right? We are passing the prescribers value to the subspecialty. As the next thing, we want to do the same, right? Pass it along all the way to the specialty. Right? And at this point, we already get the count of claims stored on this the specialty, the vertex of specialty vertexes, right? We already have a claim count there. And in order to produce the final result, we want to say order by s at claim count ESC. And that's it. The query writing is done. That's our first example, and print the final result. Okay, let's compile it. Okay, I see I received some questions. I'll try to answer while it's compiling. Why do we calling it a set while it's a single vertex? Well, it's a set containing only a single vertex, right? How can I store the path of vertex from its source? Yes, we actually, from our graph algorithm library, you can find some shortest path algorithms. And from there, you can see that how we can store the path from the source, okay? And let's just try to run it. Right, so that's, if we check the JSON result output, you can see now the specialties are already ordered by its number of claims, right, in the descending order. Okay, so let's go to our next example, and again we will go over the same set of questions to figure out how should we write the query. Okay, so the example 2 is given the prescriber. Who are the top K other prescribers sharing the most patient? Because a patient can visit many prescribers, right? So that means if we want to take a prescriber as an input, we want to see, okay, who are the other prescribers that shared the same set of patient, and we want to order them by the number of patient, right? Okay. Again, where to start from? Okay, so this one seems to be obvious because we are asking a question for a specific input prescriber. Then I think hopefully we'll just start from there, right? Otherwise, do we start from all the patient? No, start from all the other prescribers. That would be too expensive, right? Or subspecialty, not relevant. So the answer is quite obvious. What are the steps? Okay, so now we want to get another set of prescribers that shares the same patient. Then hopefully we want to have the patient in the middle, right? And what connects? We have patient in the middle. What connects between patient and prescriber? Claims. Then hopefully it's a 4-hop query starting from input prescriber to claims, and then patient, and then claims and the other prescribers, right? So that's our traversal plan. And what edge should we use? Since we already figured out what vertex to traverse, then the edge type seems to be very obvious as well, right? And then what do you want to be in the final result? Okay, so in the final result, of course, we want to have the prescribers who share the same patient and the number of patient, right? And where is the info needed for the final result? Because we are counting the number of common patients, so I would say the info is on the patient vertex set, right? And then what accumulator should we use? Then here we have a choice to make, right? Shall we use, because we are ordering the top K prescribers based on the number of common patient. So intuitively thinking, the common patient should be a number, right? A number of patients. However, if we really look at our traversal plan, between the patient and the other prescribers, we have claims. So since we have claims in the middle, if one patient has multiple claims with another doctor, then we may duplicate the count, right? We may count the same patient multiple times if we use a sum accume. Then if we don't use the sum accume, so that means we want to count a distinct number of patients. So what accumulator can help us? Oops. Right. So what accumulator can help us to count the distinct number of patients? I think that will be a set accume, because set accume can keep unique elements in its container, right? So let's do set accume. Okay, and then how do we populate the set accume? Because right now the patient IDs are here, and the final result will be printed on prescribers, right? So we need to pass the patient vertex IDs to the prescribers. Okay, now I think we have straightened out all the questions we need to think about. I just to write the where is it? Oh, here. Right, let's write a query called get top a common driver. Okay, by looking at the questions, where do we start from? The input prescriber. Oh, and we need the input prescriber, right? Then let's define a vertex type. Okay, this is where we start from. And then look back, where are the steps? So these will be the steps, and these are the edges we are going to traverse. Okay, and then let's look at the schema over here. It's easier. And then let's traverse submit queries, edges first. So then we can get claims, select the T, start and we'll traverse submit edge to the claims, right? That's the claims. And then patients, claims, and I will traverse associate edge and to patient, right? And then again, we traverse to other claims. Patients, submit. Right, but here, patient, submit, patient, submit. What do you say? From the source of the patient, the edge is submit. However, the edge submit cannot find incompatible. Oh, it's not submit, it's associate. Right. Okay, but here, since we want to get all the other claims, now the claims we already have from the input prescriber, right? Because here, if we start from patient and use this edge, it will traverse back to the claims of the starting point, right? So here, let's also define a Boolean type or a queue to prevent it from revisit the old vertex, right? So we want to say, okay, for all these claims, I mark them true. And then say, for the new claims, I want to filter them out. Right, and these are the claims, right? And after getting the claims, we want to traverse to the prescribers, all the other prescribers, right? From the claims, submit. Right, so this is our traversal plan. Okay, and then next, let's look at what accumulator do we use? Set accum. This is what we have agreed, right? So let's define the set accum because we want to use the set accum to store the ID of the patient, right? Then let's make it a set accum vertex, say patient set, right? And the next question, we want to pass the patient IDs to all the way to the prescribers, right? Pass ID to claims and then to prescribers. Okay, let's do that. So where is the patients? So here we got the patients, right? And here is where we start from the patient. And that's the place we want to pass the patient ID. Okay, then I say accum cl at patient set plus equal to, let's give you the alias. Okay, so the alias means the starting vertex, right? So if you don't just use the name, it is the vertex type representing the vertex, okay? And now I'm populating the set stored on the claim, all the other claims with this ID. And after execution of this clause, on the claim, you will have a set of patient ID. And now I'm further passing this set of IDs to prescriber. Then I will populate claims. Okay. Okay, and right now we have a set of patients stored common patient. The set of common patient is stored on all the other prescribers who shares the common patient, right? Now we want to order them by the size of the set. Okay, and then let's print them out. Okay, and that should be the query. Let me check the Q&A. What's different between accumulate and post-accumulate? Okay, that's a great question. So if you look at the select statement here, okay, line 16, we have a accum. Accum means for all the edges starting from this patient site, connecting to the claims, we want to execute this logic. What is this logic? The logic sending the ID of the patient along the edge to the set defined on the claims, so that after executing this line, the patient set on the claims will store a list of patient ID. Okay, so easily speaking, the logic after accum clause is executes on each edge being selected, and the logic after the post accum execute on every vertex being referred. Now I'm referring to claim, right? That means for each claim we connected by this edge, we'll execute this logic. That is mark the visited variable to true. Okay, and later I can use them for filtering condition. Okay, let's try to run this query. Let me find the prescriber ID first. Prescriber ID. Pre something. Okay, let me try. How about pre one? Okay, no luck. Pre 38. Oh, I need to change, select the right type. 38. Okay, and here is the top list, right? The top one is prescriber 29, has 3 common patient. Hey, it's not ordered. Oh, seems I ordered by ascending order. That's why the top one has a list of common patient, and the last one on the list has the most common patients. That is prescriber 23. So if you want to order it by descending order, you need to add this keyword. But now, yeah, just bear with me. Okay, and now let's move to the last query, and that is also the most complex one. That is how we create the referral edge, how we detect the referral relationship between the doctors, and then let's insert a new edge for that. Okay. So what does referral mean? Referral means if a patient has 2 claims, okay, 2 claims with different doctors. If the second claim is within the certain period of time after the first claim, it's very short. The 2 claims is really short, very short, and happens really soon between each other. And they are from different prescribers. That means the first prescriber referred another prescriber. So we want to detect this pattern from the graph. Okay, so again, let's ask the same set. Oh, answer is already here. Let's ask the same set of questions. Where do we start from? Since the question is given the prescriber, so I think it totally makes sense to start from this input prescriber. Okay, so what are the steps? Again, so this is also based on the, we need to find a patient that has claim with the input prescriber and had another claim after within a certain period of time after the first claim with the input prescriber with other prescribers, right? So I think the traversal plan is just the same as the previous query. We need to start from the input prescriber, go to claims, then patient, and claims, and the prescribers, right? And these are the edges will be used during the traversal. This is straightforward. Tricky part is here. What is the final result? The final result will be the referral relationship between the prescribers, as long as that they have the patient has the consecutive 2 claims, one after another, right? So the result will be the referral edge between input prescribers and the referred prescribers. Okay, so how do we identify the input prescriber and the referred prescriber? Where is the info needed for this final result? Then let's see, look at the schema. Okay, so we have patient here. Patient may have different claims. And we want to make sure the claims are between input prescriber and the other prescriber. So that means the info lies in 3 places. The claims of the input prescriber, the patient, and the other claims of the patient, right? So it is in the 3 locations, right? So then what accumulator do we use? How do we say, okay, to figure out, okay, if 2 claims is one is like one is after another, right? So of course that means we need to have the dates, right? We need the date time information of the previous claim. Okay, so that means let me try to annotate here a little bit. Can I? So that means when we start from a prescriber and we get all their claims, right? And then from all the claims, we get all the patients. So here, the second layer is patient. And then we traverse to other claims. And for the other claims, we want to figure out one thing. It is within a certain period of time, of the claims this patient had with the input prescriber, right? But in order to figure out it's within a certain period of time, we need all the dates from the previous claims with the input, right? So that means we need to store multiple dates here. Let me use a different color. Need to store multiple dates here. Okay, so what is the structure to store multiple dates? We can use set. That is a possible answer because we can store a set of dates, right, from the previous, like those are claim dates with the input prescriber. So this is the input prescriber, right? And or we can use list. List is more lightweighted. Then maybe let's just go with list, right? That would make things easier and faster. Okay, so the answer to this question, since we figured we need to we need a list accum of the dates to be put on the patient so that we can do further comparison with the claims of other prescribers, right? So how do we populate them? Then of course, since we need a list of dates defined on the patient, then we want to pass the dates of the claims of input prescriber to the patient vertex, right? Okay, then that's all the questions we need to ask. Let's write this query. Okay, so maybe create referral. let's copy the last question query a little bit because it's very similar, right? Get principal create 0. And then I need to do the same thing. Okay, and we don't need this set anymore. And also let's remove the logic populating the set. Okay, so this is our traversal plan, right? Now let's attach the accumulators to it. As we have a grid, we need to define a list of data time. Right, and if we look at the schema, it's something like this, right? We need to start from the input prescriber, traverse to the claims, and then populate the date of the claims to the patient, right? If you have multiple, then you have a list. That's what's gonna happen, right? So we're gonna populate the dates of the claims to the patient, and that will be this hop, right? That's what we do when we get the patients. Say accum patients data list equals to claims. What's the value? Attribute name, Rx field date. Right now, after executing this, we have a list of dates on the patient, right? And since we have this list of data having built, and when we traverse to the next hop to other claims, we can compare the list with the date of the new claim, right? Let's do that. Say, okay, now I want to compare each date in that list with the new claim date, right? Case when, how do we do the comparison? Let's check some document. Let's say date time functions. That's what I'm looking for. Okay, and we have datetime div, right? Okay, that's what we need. So we want to make sure the datetime div between the claim date Rx field date and the date in the list is between 0 and let's say 2 weeks. 2 weeks is this number, 14, 12 hours, 14, this number, right? This number. Okay, if this is satisfied, that means this claim is a claim being referred by the input prescriber, right? Then I want to keep this claim to the result. How do we keep it in the result? I think we can use a or accum, right? Say keep, so that we can keep it. And just mark them with a Boolean value. Okay. Rx field date. Oh, CL. We're going to keep the claim, right? Okay, and now we have the claims. We want to keep all the claims equals having this value true, because when it qualifies, I want to keep it set to true, right? And then I want to break the loop. Okay, and in the end, we can finally, from all the claims we want to keep. To the prescriber, we want to insert the edge, right? Insert into referral values input prescriber and the prescriber who was referred. Attribute. What's the attribute? Okay, I just is 0. Okay, for the attribute. Okay, give it a type. Okay, then we are good. Can we, what is the difference? Okay, can we get a copy of slides and recording for this presentation? Oh, for sure. After this webinar, we will send you all the slides and everything. Yes, code as well. Okay, and this is the query. Let's just try to run it with the same. Okay, so it seems we have 3 prescribers being referred by this input, right? And also we created the edge. And I just got another question. Say, can we practice this from a database? Yes, I'm currently using a TigerGraph Cloud instance. You can just go to tgcloud.io. And then you can start a free instance. And right now I'm using the healthcare referral network starter kit. Later you can play with it too. Okay, and so that's all my content. So by asking this whole list of questions, usually we can make ourselves think clear, like what to do when you write the queries. Okay, so maybe you can do more practice by asking yourself these questions and following the 4 steps of writing a query. And in future episode, I will have more advanced topics, say about how to define the optimized data structure, how to write memory saving queries, and as well as like how to parallelize the query in order to get better performance. Okay, and David, I think I'll hand it to you.
Okay, great, thanks. Can you stop sharing, pass me back control? Perfect, thanks. Okay, so I think in the interests of time, Xingyu, that was an excellent presentation, absolutely incredible. I learned a ton, great job. I think in the interest of time, we'll just move forward and wrap up the presentation. I know there are a couple of questions that we haven't addressed yet, but we will do that in the follow-up emails, the post-webinar follow-up emails. So if there are more questions, there's at least a couple of ways for you to get those questions addressed. Of course, you can also reach out to Xingyu directly, but we have our developer forum, and we recommend that you join that forum. It's a great way to not only hear from us, but hear from other people from within the community who are dealing with issues that might be very similar to yours. And in that way, that might be a more effective way for you to get answers to the questions. And additionally, every Thursday at 11 a.m., well, it's now PDT, Pacific Daylight Savings Time, 11 a.m. Pacific Time, we hold our developer office hours. That's a live online session for anyone to submit a question, and I have one of our subject matter experts address it. As Xingyu said in response to that question, we encourage you to try TigerGraph Cloud. That is an excellent way, probably the best way to get started on a database. And it's free. It takes about 6 or 7 or 8 minutes only to get started. And there's a free tier, free in perpetuity, And then there's additional, if you want to get access to additional starter kits, increase the quantity of starter kits, you can submit a credit card. We'll give you $25 in credit, which is typically, 10 hours or so, for you to try other starter kits as well. Additionally, it's worth pointing out that if you do have one starter kit within that free tier and you decide you want to switch, you can always delete that starter kit. Now, you will lose all of the data and any changes to the schema and so forth that you've made, but that's another way for you to continue using the platform for free. So really, there's no reason for you not to start using TigerGraph Cloud, right after we've finished this webinar. At your earliest convenience. There's additional ways for you to get information. They're listed here. In the interest of time, I'm going to move forward now and just talk about our next couple of webinars. Our next webinar will be next week, Tuesday, which is worth noting. Our usual webinar schedule falls on every Wednesday, but our next one will be next Tuesday, March 24th at 11 a.m. Pacific time. And this is being hosted with our partner Expero. And that will add even more, that will enrich even more the experience, I think, for everybody in the audience. The topic is a roundtable on fraud detection with graph and machine learning. And if anybody's interested in the second episode of this series that Xingyu has just kicked off, episode 2 tentatively is scheduled for April 8th. So in about 3 weeks, if my math is correct, that will be on Wednesday, April 8th. And that brings us to the end of the webinar. I know we ran a few minutes over. I appreciate everybody staying to the end. We know you are very busy. There's probably a lot of things you could have done in this past hour. We're flattered. And I really appreciate you choosing to spend the time with us. We hope that our enthusiasm for Graph has rubbed off. I was going to say contagious, but that's probably not the right thing to say, given our current health and economic crisis. But we hope our enthusiasm has rubbed off on you, and we would love to see you at a future one of these webinars. But for now, that brings us to the end. Thank you for joining us. We hope you found this informative.